All right, so this next assignment, calculating properties, and what you got to do is basically you got to fill out this chart. And I've set up a Jamboard I'm going to work with right now to try and go through how we would do this. So you need to find the mass of all of these objects. You need to find the volume in US units, so inches cubed. You need the density in US units as the density weight, that is pounds, inches cubed, and then we need to convert that to the density in metric, which would be grams, centimeters cubed. Okay, so let's go over to Jamboard and look at this. So the first step is we've got three values. We've got a Delrin spheres, steel spheres, and wood rectangles. And these are made up values, so you don't got to worry about if you calculate your volume later or your density later and you're like, that's not the density for Delrin. The values are all made up. What we would typically do is in class, we would measure these ourselves. Like I'd give you a Delrin sphere and we'd do the volume and the weight measurements and then we do the calculations. But that's obviously not able to happen, so we're just going to do the calculations. Okay, so just looking at this right here, we've got three values. Each of these values has given its weight in pounds. And to convert all of these pounds to mass, what we have to do is we have to multiply each of those values by this much. So the Delrin is going to be 0.003 times 453.59. The steel is going to be 0.0185 times 45359, and finally the wood is going to be 0.0092 times 453.59. And I got my calculator over here, so let's punch these values in. So we'll start at 0.003 times 453.59, and we get 1.36. So that's what I'm going to put in. I'm going to put in 1.36, and that's where I'll leave it. And that would, of course, be grams. Just put the G. Grams. Then I have my steel, which is 0.0185 times 453.59, and I'm getting 8.39. I'm going to go with 8.39 grams. And then for the wood, 0.0092 times 453.59, and I'm going to say 4.17 grams. Okay, so those are my values. I'm going to need them again later, but for now, that's fine. So you could actually put each of those in your chart. Okay, so for the next bit, it gives us three measurements, and in the end, what it wants on our turn-in sheet here, it wants the volume of the samples. It wants the average there. So it doesn't want each individual one, it wants the average. So it wants the average of these three. And there's kind of two ways to go about this. The first way is that you would solve for each individual one of these, the volume, and then you would add those three answers up and then divide them by 3, and that would be your answer. Or you could look at these and say, hey, this and this are one above this. If we average these three together, the average of these three is going to be 0.498. And I mean, if you don't believe me, we can put in the calculator. We can go add the 3 up and divide by 3. 0.497 plus 0.498 plus 0.499 divided by 3, and we get 0.498. So we can just figure out the average diameter for all these threes, and then take the average diameter and do the formula for that. So that's what I'm going to do. So I'm going to do volume average equals 4/3 pi times radius cubed. So this is the average diameter. So to get the average volume, I have to divide it by 2. So let's get my calculator back out. 0.498 divided by 2. Okay, so I get 0.249. So let's fill in the things. So volume average equals 4/3 pi times 0.249 cubed. Okay, and we can probably just punch this all straight in the calculator. Yeah, I got a powers up button here. So if I was to punch this all in the calculator and I did 4 divided by 3 times 3.14 times 0.249 to the power of 3, I would get 0.0646. So when you get all that through the calculator, you get 0.0646 inches cubed. So this is going to be your answer for this problem. So that is how you do it. You just plug it all in the calculator. Very straightforward. It's really just a matter of figuring out what your average is there for the measurements. So moving on, the Darylin is, or this should be steel, my bad. So the steel, the steel should be the same procedure. You have to find the average of these, which is going to be, same kind of deal. The average is going to be 0.499. So if I'm looking at this, I'm going to say average diameter is 0.499. You can plug it into the calculator if you don't believe me. I'll do that right now. So 0.49 plus 0.499 plus 0.5, enter, divided by 3. You get the 0.499, so there is the average. You're going to divide that by 2 to give you the average radius. The average radius is going to equal 0.499 divided by 2. Could be 0.2495. So we got that right there. So that's the average radius. So now when we do our formula, same as before, average volume equals 4/3 pi radius cubed. We're going to substitute in our values, and then we're going to put it in the calculator. 4/3 pi 2495 cubed, which is going to equal, when that all goes into the calculator, so let's clear it out, parentheses 4 divided by 3 times 3.14 times 495 to the power of 3. Answer is slightly larger than the last one, which is not a surprise. 0.065 is what we'll go with. Inches cubed. Okay, so that is the answer to this one. Moving right along, we have wood. Now, wood is not so straightforward to get the average for the wood. What I'm going to have to do is I'm going to have to calculate the volume for this and then add those 3 volumes together. But the nice thing is the formula for the volume of this is just multiplying these 3 numbers. So you can just look at this like we're going to do this for all of them. And then we will add all 3 of them up and divide by 3. So this one is not too bad in terms of straightforward math. It's actually an easier calculation. So we get 0.749 times 0.752 times 0.757, which gives us a volume of 0.42638. That's probably more than I need to do. And then the next one, same kind of procedure, 0.749 times 0.752 times 0.743, enter. It's volume of 0.41849, being consistent in the amount of spaces I'm giving it here. And then finally 0.757 times 0.752 times 0.743, and I get 0.4229 inches cubed. So I'm going to add these together. I'm going to do plus, and I'm going to do 0.41849 plus 0.42638. And that's going to give me 1.2678 is enough. And to find the average of those, I have to divide by the number 1, 2, 3. So divided by 3 is going to equal 0.422. We'll say 0.422 inches cubed. So that would be my volume for the wood. Now, all depending on how you round these is going to affect your answer. So like, this is a very ballpark figure here. As long as you get like around 0.42, that would be fine. Like if you were like 0.419, 0.43, anywhere in there, I'd probably would have accepted, depending on how you carry decimal points out. Okay, so moving on. So moving right along. So we've got to do the formula for density weight, which is weight equals volume times density weight. Now we don't have the density weight, but we do have the volume and we have the weight. So we might have to go back to previous pages for that, but that's the formula we're going to use. So we're going to use density weight equals weight divided by volume. So density weight equals, and I'm going to have to go back quickly because I don't have this written down. So it's 0.003 for the weight and then the volume is 0.0646. And I should really write all this down, but weight is 0.003, 0.0646. So the density weight equals, and this is pounds, inches cubed. If I pop that into the calculator, 0.003 divided by 0.0646, enter, and I get an answer of 0.0, we'll say 46 pounds, inches cubed for my units. So there we go on that one. It is exactly the same for all of these, so it's going to be density weight equals weight divided by volume. Density weight equals, and once again I have to strike through the pages, and I'm writing it down on my tablet, so when we get back to the page it'll be there. So density weight equals 0.0185 pounds and 0.065 inches cubed. So we got that there, and we're going to put that in the calculator here. 0.0185 divided by 0.065, and we get a density weight of 0.28. I'm going to say 0.284. I'll bring it over one more. 0.284 pounds, inches cubed. And the wood. So our weight for the wood is going to be, one more page, sorry. Weight for the wood is 0.0092 pounds, and we had a volume for the wood on average as 0.422 inches cubed. So we have a density weight equal to, if we're going over here, 0.0092 divided by 0.422. And we get a density weight of 0.0, I'm going to say 0.022 pounds, inches cubed. Okay. So that is all of these. Now what we have to do is we have to take these values and we have to basically multiply all of them by this magic number. How do we get this magic number? Well, that is simple. We set up a big conversion. So we had to set it up so 1 pound inch cube, which is what our density weights units are, becomes 1 kilogram, and then becomes basically 1 gram over centimeters cubed. So to do that, we have to put desired over given. So, 1 kilogram over pounds mass is going to let us get rid of the pounds. And then 1 kilogram over grams gets rid of the kilogram. Then 1 inch over centimeters gets rid of the inches. And it's all cubed. So that lets us cross out all of these units. And when you do that and you multiply all of this out, you get this number right here. And if you want, you can do that yourself if you don't believe me. But you can take my word for it. And I'm just going to do them all here because all of these are going to be, density mass equals 27.68 times whatever your value is. So that would mean the value for this one, what's this one, the Delrin, is going to be times 0.046 the density mass for the steel is going to be, going over one more, 0.284, and the density mass for the wood is going to be 0.022. Okay. So if we multiply this out, we're going to get delrin equals 27.68 times 0.046, and we get 1.273, and that is grams centimeters cubed. The steel equals 27.68 times 0.284, which is going to be 7.86, and we'll go to 1 just to be consistent, grams centimeters cubed. And finally, to finish off the assignment, the wood, and wood is good, we're going to get 27.68 times 0.022 equals 0.60, and I'll say 9 grams centimeters cubed. Okay, so that is it. That is the whole assignment there. I hope this was all helpful. If your answers are off slightly, like within a tenth, you're probably fine based on rounding. But otherwise, you should probably look it over and check to see where you went wrong if you're like more than a tenth off. Okay, so I finished this right before class starts, so I got to get to class. Hope this is helpful to you guys. Good luck.